First, let us ask, what is the spring that drives all? All this energy emanates from one single center, one single source, the sun.
Okay, so there we go again. You see our amperage output there. FlowerPower device. I'm going to crank this up once again, and we're going to look at the output voltage. Now that does affect our. You see, that's about 1500 volts right there. That's all the way to the top, through the top, all the way down there. So that joker's really cranking. It does affect our current reading when we put the scope probe on. So I'm going to pull the scope probe now, and you can see it bounce back up. Okay. One final thing we're going to do here. As you can see, I've got my digital voltmeter over here. I'm going to connect the negative to the bus. So it's hanging out on the bus there. The positive's on the bus. And you can see we're at 12.24 volts at that point. So you see our current reading here. I'm going to grab this, pull it off. Okay, that's how much current we're drawing to run the FlowerPower in solid state mode, which is like nil. I mean, it's really, really low. It's probably down in 5, 10, 15 milliamps, somewhere around there. It's 12.25 volts. So you saw our voltage output from the FlowerPower and the amperage there between the FlowerPower and the transformer. You saw the output of one leg of the transformer, both in voltage and amperage, and you see input voltage and amperage there. A couple other plans I have here for some little more tweaking. We've got a 15 ohm for a very fine tuning pot. We've got 2K, 5K, and 10K, just to increase the range of what we can do. What we can do with the solid state mode and how high a sweet spot we can find there. I thought these were cool. This symmetry really is strong material, even at a macro scale like this. Lattice something together like that at a crystal scale, and boy, watch out. Okay, we've got I got the Mondo capacitor as well. This is a 1 farad capacitor. It's got a digital voltmeter in it. And as you can see, I haven't even opened it out of the package yet. That brings me to another point regarding some wire. You guys see here, I've got spools of 8 gauge or 4 gauge there on the top. And then there's a spool of 8 gauge hiding back there behind the nails. You can't quite see it too well. That's the warrior that protects me from Kiribati. It's Maori.
The scientific man does not aim at an immediate result. He does not expect that his advanced ideas will be readily taken up. His work is like that of the planter for the future. His duty is to lay the foundation for those who are to come and point the way.
Okay, so for my final performance tonight, I'm going to start up the FlowerPower device in rotor mode. We're going to use this rotor over here to do so for us. Which right now has a little induction coil and some light flowing. LEDs sticking into acrylic tubes. And it's got its little satellite rotor there, 1/8 inch satellite rotor inside the doorbell coil, lighting these little LEDs very faintly. This material is pretty interesting. I picked this up at the surplus house. This is some kind of 1-inch piping, but it's a fiberglass, it looks like, a layered fiberglass. So it's pretty strong. It was darn hard to cut there, but I'm using that for the rotor housing on this one. So first off, let me reconnect our charging battery here. And we'll spin this down. We'll remove the top coil. We'll place the rotor in the general vicinity of where it needs to be. And now I'm going to take my scope probe and I'm going to put it on the pulse DC output. That's channel 1. We'll set that to 0.1 microseconds. And you can see the noise there and the bounce. A lot of that's coming from the other motors that are running. And you can even tune it. Oh, it looks like it's trying to self-start there. I don't see our rotor moving though, so it just could be, that could just be resonance. Yeah, it's not actually moving. So what we're going to do, is I'm going to set this here, and I'm watching the scope, so I'm going to pick up this other rotor, I'm going to bring it in, and as you can see now it syncs. And I can move the knobs. Now the rotor's actually moving and triggering things. And I'm just slowly turning the knob there and increase the frequency there that much. So I'm going to put this coil back on top. I'm going to look down inside and I'm going to line up the housing with the middle, with everything trying to be as vertically aligned as possible. So here you see our pulse DC output. I'm going to scale that down in frequency a little bit. And I'm going to go ahead and pull the charging battery again. Okay, I had to change my voltage output there. So this is what we're seeing on our pulse DC output now, okay? And that's on 20 volts per division. So I'm going to hook the charging battery back up. The scope now wants back to a more reasonable voltage level for that. So now that's on 5 volts per division. I think I can clean that wave up just a little bit by attaching the ground of the scope to our, we can clean it up just a shade there. Okay, so there's the FlowerPower running now. And I'm going to go ahead and crank it up a little bit. This is about in the normal running range, somewhere in here. When it starts to wig out and break into many waves that have interference patterns, that's when we're nearing our maximal output. I'm going to get to this one, I promise. I really am. I've been slacking, but I'm going to get to this one because it's going to be fun. This is still one of my favorites. It's a little old school hard drive Bedini monopole. That was the power I just kicked off.
shall know exactly what electricity is, will chronicle an event probably greater, more important than any other recorded in the history of the human race. Then it will be a mere question of time when men will succeed in attaching their machinery to the very real work of nature. See the excitement coming.
Rising up, cause on election day, we'll see who's banned in the USA.